Let's evaluate the integral 0 to a root over a minus x by x dx. Of course, when I write x equal to 0, this quantity remains undefined. But what we say is that this integral is still computable. Let's compute it. We start by writing let I equal to, let's compute the indefinite integral root over a minus x by x dx. Observe that we have square root of a minus x in the numerator as well as in the denominator. So how can I remove the square root? Obviously, or no, rather, we can take x equal to a sine square theta. 1 minus sine square is cos square. So root and square will get cancelled. But denominator, yes, a sine square theta, root and square will get cancelled. So let x equal to a sine square theta. But we want to change dx with d theta, so let's differentiate both sides with respect to theta. d theta. We differentiated both sides with respect to theta of the expression x equal to a sine square theta. So we obtain dx d theta equal to dx by d theta equal to derivative of a, that's a constant, we don't have to differentiate it. Sine square theta, if you differentiate it, you will get 2 sine theta into cos theta. So we can write dx as a into 2 sine theta into cos theta d theta. Okay. So what about integral now? This implies we want to evaluate this integral. I equal to x equal to a sine square theta, a minus x. So let's write it as it is. A minus a sine square theta. What about denominator? Again, x equal to a sine square theta, dx equal to 2a sine theta cos theta d theta, 2a sine theta into cos theta d theta. Okay. Now if we take a common, then a will get cancelled and you are left out with 1 minus sine square on the numerator. 1 minus sine square is cos square and square root of cos square is just cos theta. Whatever root of sine square theta, that's again just sine theta. A got cancelled. 2a, that's a constant, we write it outside the integral. Sine theta into cos theta d theta. Well, we can cancel sine theta once again, or rather we cancel a here, so we cancel sine theta here. Now cos square theta, how do we integrate it? Well, one simple method is cos square theta, we can write it as 1 plus cos 2 theta by 2. Now we know how to integrate half. That's just half times you are integrating with respect to theta, so theta. And integral of cos 2 theta is sin 2 theta by 2. This 2 is also there. Of course, plus some constant of integration. But we have started with x, not with theta. So what is x here? X equal to, theta equal to root over x by a, or rather theta equal to sine inverse of root over x by a. Oh, we can cancel 2 here. Theta equal to a is constant, so we keep it out. 2 we get cancelled, theta equal to sine inverse of root over x by a. Here 2 got cancelled, sine 2 theta can be written as sine theta into cos theta. Sine theta is root over x by a. Cos theta is root over 1 minus sine square theta. Again sine square theta is x by a. Here sine square theta is x by a. Now, therefore, we want integral 0 to a root over a minus x by x dx. Since when I write x equal to 0, this quantity remains undefined. So what we do is we take the limit. So the integral equal to limit h tends to 0, integral from h to a root over a minus x by x dx, and that's equal to limit h tends to 0, a as it is, sine inverse of root over x by a plus root over x by a into root over 1 minus x by a, limit from h to a. Now when I write x equal to a, sine inverse of 1 is pi by 2. When I write x equal to a, this vanishes, plus 0 minus, as h tends to 0, sine inverse of 0 is 0. As h tends to 0, this is again 0. So this is just equal to pi by 2. So we computed it. Therefore, integral root over 0 to a root over a minus x by x dx equal to pi by 2, even though this function is not defined at x equal to 0.